Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on the engineering surveys for the highway alignment. The various sorts of engineering surveys which have to be done for the fixation of the highway alignment are: first, the map study; second, the reconnaissance survey; third, the preliminary surveys; and lastly, the final location and detailed surveys. Now, to start with the map study. If the topographic map of the area is available, it becomes possible to suggest the likely route for the road. In India, the topographic maps are available from the Survey of India department, and the main features like the river, hill, valleys are shown in these maps. The careful study of such maps makes it possible to have an idea of the several possible alternate routes so that the further details of these maps can be studied and the probable alignment can be located on the map from the following details available on the map. That is, first, alignment avoiding the valley, ponds or lakes. Second, when the road has to cross a row of hills, possibility of crossing through a mountainous pass. Third, to avoid the bend of the river. Next, approximate location of the bridge site for crossing the rivers, which will help in order to avoid the bend of the river. And the map study gives a rough guidance of the routes to be further surveyed on the field. Next is the recognition survey. Now, the second stage of surveying for the highway location is the recognition survey, in order to examine the general character of the area for deciding the most feasible routes for the detailed studies. A field study party of experts may inspect a fairly broad stretch of land along the proposed alternative routes of the map on the field, and only a very few instruments like the Abney level, tangent, clinometer, barometer, etc. are used by the recognition party to collect the additional details rapidly. But it should be noted that they are not much more accurate, and all the relevant details not available in the map are collected and noted down. Some of the details to be collected during the recognition survey are as follows. First, the valley, pond, lakes, marshy land, ridges, hills, permanent structures, and other obstructions along the route which are not available on the mark, they are noted down. And an approximate value of the gradient, length of the gradients, and radius of the curves of the alternate alignments are noted. The number and type of cross drainage structures making flood level, maximum flood level, and natural ground level along the probable routes, they are being fixed. The soil types along the routes from the field identification test and observation of the geological features is being done, and the sources of construction materials, water, and location of stone quarries is marked. When the road passes through a hilly or a mountainous terrain, additional data regarding the geological information, formation, type of rocks, the dip of the strata, seepage flow, etc., has to be observed so that it can be decided the to help the stable and the unstable site of the hill for the highway alignment. As a result of these few alignments may be chosen for the further study based on the practical considerations observed on the site. Next is the preliminary survey. The main objective of the preliminary surveys are to survey the various alternative alignments which are proposed after the recognitions and collect all the necessary physical information and details of the topography, the drainage, and the soil. to compare the different proposals in view of the requirements of a good alignment, taking in consideration all the features, the local site conditions, the material availability. The comparison is being done and a feasible economical proposal is being selected. Next is to estimate the quantity of the earthwork material and other construction aspects and to work out the cost of the alternative proposal. By this estimation of the quantity of the earthwork material and other construction aspects, a economical comparison can be done and the selection of a economical as well as a feasible proposal can be suggested. The preliminary survey is carried out by the following methods. First, by the conventional approach. Second, the rapid approach. And third one, the modern techniques by use of the global positioning systems. Now, in the conventional approach, it is a survey in which the survey party carries out the survey using the required field equipments. They take the measurements, collect the topographical data and other data, and they also carry out the soil surveys. Now, in case of the modern rapid approach, here a serial survey is being undertaken, which is by the aerial photographs and by the photogrammetric methods and the photo interpretation techniques for obtaining the necessary topographic and other maps, including the details of the soil and geology, is being done. The procedure for the conventional methods of the preliminary survey includes the following steps. First is the primary traverse. This is the first step in the preliminary survey, which is to establish the primary traverse following the line recommended in the recognitions. Now, for the alternative alignments, either secondary traverse or independent primary traverses, they might be necessary. As these traverses are open traverses, there is no adjustment for errors is possible. So, the angles should be very accurately measured by the theodolite, and the length of the center line should be measured by using very good and accurate chaining methods or by tachometry or by some modern instruments. Next is the topographical features. Once the center line is fixed for the of the preliminary survey, the topographical features are recorded, and all the geographical and other man-made features along the traverse for certain width on either sides are surveyed and they are plotted. The width to be surveyed is generally decided by the survey party, but the absolute minimum width is the land width of the proposed alignment of the highway. Next, leveling work. Leveling is carried out by side by side to give the center line profiles and typical cross sections. The leveling work in the preliminary survey is kept to a minimum just sufficient to obtain the approximate earthwork in the alternate alignments. Now, the drainage studies and hydrological data. The drainage investigations and hydrological data are collected in order to estimate the type, number and approximate size of the cross drainage structures. Also, the vertical alignment of the highways, particularly the grade line, is decided based on the hydrological and drainage data, such as the high flood level, the ponded water level, depth of the water table, amount of surface runoffs, etc. The soil survey. Soil surveys are an essential part of the preliminary survey, as the suitability of the proposed location is to be finally decided based on the soil survey data. Here, the soil survey conducted at this stage also helps in working out details of the earthwork, slopes, suitability of materials, subsoil and surface drainage requirements, and pavement type, the approximate thickness requirements, etc. All these details are required to make a comparative study of the alternate proposals. Next is the material survey. The survey for the naturally occurring materials like the stone aggregates, soft aggregates, etc., and its identification of suitable quarries has to be made. Also, the availability of the manufactured materials like the cement, lime, brick, etc., and their locations are to be ascertained in the material survey in order to have the least travel distance of this raw material for the construction of the roads from the quarries and the man-made materials like the cement, lime, bricks, etc. to the road construction site. Next is the traffic studies, primary traverse. The traffic surveys conducted in the region form the basis for deciding the number of traffic lanes and roadway width, pavement design, and economic analysis of the highway projects. The traffic volume counts of the classified vehicles are to be carried out on all the existing roads in the region, preferably for the 24 hours a day for a total period of 7 days. And the origin and destination studies or surveys are very useful for deciding the alignment of the roads. These studies can be carried out on a suitable sample of vehicle users or drivers. In addition to this, required traffic data also may be collected so that the traffic forecast can be made for 10 to 20 years period. The final location and the detailed survey. The alignment finalized at the design office after the preliminary surveys is to be first located on the field by establishing the center line, and the next detailed survey should be carried out after collecting the information necessary for the preparation of the plans and the construction details of the highway project. The alignment that has been finalized in the design office after the preliminary survey is to be first located on the field by establishing the center line. That means the fixation of the center line from the plan on the site has to be done first. Next, the location survey has to be done. And this is being done using the transit theodolite and by staking of the center line. The location of the center line should follow as closely as practicable the alignment finalized after the preliminary surveys. The major and minor control points are established on the ground and center pegs are being driven, checking the geometric design requirements. Here, certain modifications in the final locations may be done on the field if found essential, and the center line stocks are driven at suitable intervals, say at 50 meters interval in the plain and rolling terrains and at 20 meters in the hilly terrain. Detailed survey. Now the temporary benchmarks are fixed at an interval of about 250 meters and at all drainage and underpass structures. The levels along the final center line should be taken at all the stacked points. The leveling work is very important as the vertical alignment, earthwork calculation and drainage details are to be worked out from the level notes. The cross section levels are taken out up to the desired width at an interval of 50 to 100 meters in the plain terrain and 50 to 75 meters in the rolling terrain, 50 meter in built up areas and 20 meter in hilly terrains. The cross section may be taken at a closer interval at horizontal curves and where there is an abrupt change in the cross slopes. The detailed soil surveys should be carried out in order to investigate the strata beneath, and the CBR value of the soils along the alignment should be determined for design of the pavements. The data during the detailed survey should be elaborate and complete for preparing the detailed plans, design and estimates of the project in order to get the exact overview of the materials availability, the site conditions available for the design and estimate of the projects. The drawings and the report. The following drawings are usually prepared for the highway project. First is the key map, which shows the proposed and existing roads and important places to be connected. The size of the plan generally should not exceed 22 by 20 centimeters, and the scale of the map is chosen suitably depending upon the length of the road. Second is the index map. The index map should show the general topography of the area, and the details are symbolically represented. The index map should also be of the suitable scale, and the size is 32 by 20 centimeters. Third is the preliminary survey plan, showing the details of the various alternate alignments, and all the information collected should be normally drawn to a scale of 10 centimeters equals to 1 kilometer to 25 centimeters equals to 1 kilometer. Next is the detailed plan, showing the ground plan with the alignment and boundaries, the contours at an interval of 1 to 2 meters in the plain country to a scale of 1 as to 2400, and in closed country a scale of 1 as to 1200 may be adopted for the detailed plans. The size of the drawings may be A2 size or 60 by 42 centimeters approximately. Next is the detailed cross section, which are generally drawn to a natural scale of 1 centimeter equals to 2 to 2.5 meters. The cross section should be drawn at every 100 meter or wherever there is an abrupt change in the level. In the hilly roads, the cross section should be drawn at a closer interval, and the cross section drawings should extend at least up to the proposed right of way. The cross section number, the reduced distances and the area of filling and or cutting should be shown on the cross sectional drawings. Land acquisition plans. The land acquisition plans are usually prepared from the survey drawings for the land acquisition details. These plans, they show the all general details such as the buildings, wells, nature of gradients and other details required for assessing the values. The scale adopted may be 1 centimeter equals to 40 meters or less. Drawings of the road intersections. The drawings of the road intersections should be prepared showing all the details of the pavement, shoulders, islands, etc. to a suitable scale. And lastly, land plans for quarries. Where the quarries for the construction materials are to be acquired for the new projects, separate land plans they should be prepared. The size of these plans and the scales may be similar to those suggested under the land acquisitions. That is generally to a scale of 1 centimeter equals to 40 meters or less. The steps in the new project report. The new project report may be divided into the following stages. First is in regards with selection of the route, finalization of the highway alignment and geometric design details. Second is the collection of materials and testing of the subgrade soil and other construction materials, the mixed design of pavement material and designing details of the pavement layers. whereas the third stage is the construction stage, including the quality control. In this, the steps followed are as follows. First, the map study. With the help of the available topographic maps of the area, the map study is being done. Second, the recognition survey, which gives us the general idea of the topography and other features on the field. Identification of the soils, the survey of the construction materials by and on the spot inspection of the site. Next is the preliminary survey. The preliminary survey gives us the topographic details and soil survey along the alternate alignments, consideration of the geometric design and other requirements of the alignment, preparation of the plans and comparison of the alternate routes. The location of the final alignment. The transfer of the alignment from the drawings to the ground by driving pegs along the center line of finally chosen alignment is being done. Setting out geometric design elements by location of tangent points, apex points, circular and transition curves, elevation of center line and super elevation details. Next is the detailed survey. Now in the detailed survey of the highway construction work for the preparation of the longitudinal and cross sections, computations of the earthwork quantities and construction materials is done, and the checking details of the geometric design elements has to be done. Next, material survey. The survey of the construction materials, their collection and testing is done in the material surveys. Also, the quarries, sites available to the construction site are being established in the material surveys. Next is the design. The design details of the embankment and cut slopes, the foundation of the embankments and bridges and pavement layers is done in the design details. Next is earthwork. Excavation for highway cutting and drainage system and the construction embankments has been done by the earthwork investigations. In the pavement construction, the preparation of the subgrade, construction of the subbase and construction of subbase and surface courses is done. And lastly, the construction controls. Here, the quality control tests during the different stages of the construction and the checking for the finished road surface such as the unevenness, the camber, the super elevation and extra winding of the pavement at curves is checked. For a project, the various steps are to be followed. The steps are as follows. Recognitions of the stretch of the road to be realigned. Next, survey of the existing road has to be done in order to get the on-site conditions of the road. Next is the observation of the spot levels along the center line of the road and cross-section levels at the suitable intervals in order to get the field condition of the site. Soil surveys along the stretches of the land which the realignment road may pass in order to get the soil, details of data of the soil strata. Next is the finalization of the design features of the realigned road stretches. Depending upon the above information, the finalization of the design features of the realigned road can be done. Next is to prepare all the drawings and marking out the center line on the site. Earthwork and preparation of the subgrade for the realignment road stretches, setting out the construction of the new bridges and culverts is done, and then the checking of the geometric design elements of the newly aligned stretches of the road has to be done. Lastly, the design and construction of the new highway pavements is being made possible. With this, we shall stop. Thank you.